Topic 8-3, adding and subtracting and multiplying radicals. We're dealing with more of the same, just more and more practice of this. We'll get better at it. Your whole textbook shows this in Chapter 11, Section 7, starting on page 811, and also in Section 7, and also in Section 8 on page 816. On page 820, you'll see a reference to using radicals in electricians would use radicals to tell how much current would be running through an appliance. Also on page 807 in our textbook, it gives a sports application about how to find how far the third baseman would throw the ball to the first baseman, and it would be a right triangle, so you'd be using the Pythagorean theorem, which in turn use radicals. So there are applications to what you're doing in this section. Okay, look at the first one. You've got a few that are like terms, so those are underlined. We've gotten in the habit of highlighting these as well. So these two can be added together to become 9 square roots of 3. And the like term of the 4, and that's understood to be a -1, both the 4 and a -1 square roots of 2, combine a +4 and a -1 becomes 3. So again, you're combining your like terms for each of these. Number 2, you had to actually find the like term first, but notice you do end up with like terms once you take this square root of 12 and this square root of 75 to its simplified form. So if you need to see that a little separately, remember we were circling pairs. 4 times 3 is 12, and 4 is a pair of 2's. 25 times 3 is 75. 5 has a pair, so these are the ones that factor outside the radical. Whatever I circle goes to the outside. The pair of 5's moves to the outside of the radical. What you have to remember is that you're going to multiply. So you might want to put that there just for your reference to remember that you do the multiplication of that 5 times whatever's on the outside, a -2. That's where the -10 comes from. You've got a pair of 2's, so 2 is multiplied to 4 to get your 8. What stayed under? Our square roots of 3's. Notice how they stay under the radical. Now we have our like term, so you're just combining your 5. The 4 times the 2 became your 8. And then we'd already said your -10. So you can use a calculator, but if you add this together, you're taking 8 and 5 is 13. 13 minus 10 is 3. This stays as a like term for your radicals. So 3 square roots of 3 for that one. Again, pause this and study that if you need to. Okay, now we're mixing it up. We've just done some addition and subtraction, and now we've gone to multiplication. Remember, in multiplication, you multiply your whole numbers, the 3 and the 5, to get the 15. Then you multiply what's under your radical sign, the 6 and the 2, to get 12. Again, we'd already factored 12 over here to 2 square roots of 3. So a pair of 2's, and you have a 3 that would stay under. So this right here is what square root of 12 is. So if that helps, you can say, okay, well, I've simplified the square root of 12 to 2 square roots of 3. But I have to make sure I multiply that 2 by what was already multiplied in my whole numbers to the outside of my radicals. So that's where that 15 times 2 becomes 30 square roots of 3. This one is like 2 of these. You're thinking square root of 2. If you want to show it the way this is shown, that's 2 to the power of 2. And the radical, 3 square root of 3 to the power of 2. But if you would like to know that that's also, what that means is it's 2 square roots of 3 times 2 square roots of 3. This 2 and this 2 become 4. Square root of 3 times square root of 3 is 9, which just becomes 3. So then this whole problem has the radical go completely away to just become 12. All right, 2 more. This one has a parenthesis. With a parenthesis, you want to make sure you distribute. So I like to show arrows when I show distribution. So put your arrows. Because there's 2 arrows is because of this. There's 2 terms inside my parenthesis. So anything inside the parenthesis is going to be multiplied by the term on the outside of the parenthesis. Therefore, this is square root of 6, and this is square root of 15. Those can't be combined, so your answer is square root of 6 plus square root of 15. Okay, so again, if this helps, highlight your your parentheses, and then show your arrows of multiplication. I sometimes help students and they tend to add. They'll say this is 6. They'll say this is 10. But be really careful. You're multiplying, not anytime there's a parenthesis on the outside, you're doing multiplication. 3 times 3 is 9. 2 times 8 is 16. 3 times a negative 4 is a negative 12. And the square root of 2 times the square root of 3 is square root of 6. So this factors to a complete pair of 4s. They didn't show that, but I'll go ahead and show that pair there. So that a square root of 16 is 4, and then 4 times 9 is 36. That one doesn't factor any more completely, so that your final answer would be this one right here. So notice these two have 2 different radicals with pluses and minuses between them. If it's in its simplest form and they don't have a like term radical, you can't combine them. So leave them separately. Don't add these 2 numbers now that there's an addition separating them. Just remember the radicals would have to be the same. Like in problem 2, the reason we were able to combine all of those is because they were all a square root of 3 as its like term. And that concludes 8-3.